Okay, guys, we are going to go ahead and get started. And so we are going to do a few examples from your very last homework section. I'm sure you're very excited. Um, and so I want to make sure that everybody realizes we are going to be in section 6.1, but only part A today. So you won't see 6.1b listed in your homework list. You do not have to do that in any way. And 6.1a really builds quite a bit on the homework assignment that you had due on Tuesday of this week. And so we are going to do a couple of things. So when you talk about section 6.1, you're going to hear the word asymptote. And the first thing that we're going to do is we're going to talk about this for just a second. It is the weirdest word in math, in my opinion, at Asymptote. So asymptote. There are actually 3 different kinds of asymptotes, but in this class, we're only going to do 2 of them. So the only ones that I am going to write down right here is a vertical asymptote and then a horizontal asymptote. And there is something called an oblique asymptote. And if you go through everything in Hawks, you will see mention of an oblique asymptote, but none of your homework problems will have those on there. So for purposes of this class, you don't have to worry about that. Now, if you get into things like pre-cal and calculus, then you may very well run into those, but at least not for college algebra. So what an asymptote is essentially on a graph is you are going to draw these things with a dashed line. So if we're talking about a vertical asymptote, remember vertical is up and down. And so we would draw a vertical asymptote as just a little dashed line that is going to go up and down. And we would draw a horizontal asymptote as, remember, horizontal, the way to remember that is the horizon. So if you look out to the horizon, it is left to right. And so we would draw that as a left to right line, and it is always drawn as a dashed line. One of the reasons that it's dashed is you need to be able to tell the difference between an asymptote and the actual graph. And when we actually graph something, we draw it with a solid line. And so that's one of the ways that you can tell the difference of these things. Now, typically what happens is on an asymptote, a graph gets very close to the asymptote. But doesn't usually cross it. And I'm going to say usually cross it. The reason I'm going to say that, you may have heard in the past, depending on if you've heard of these things before, or if you just came straight out of high school and you happen to remember doing them in Algebra 2 or something like that, you will hear people say that graphs get really close to asymptotes, but they never cross them. Yeah, that's true about 99% of the time. I can give you an instance where it does, and so that's why I'm going to say it does not usually cross it, because I don't want you to think, 2 years down the road when you find one of these incidents that your math teacher lied to you. So not normally does one of these does a graph cross the asymptote. So what we're going to do first, before we actually look at these in a graph or anything, is we're going to figure out how to find them. All right. And so the way that we are going to do that is I'm just going to give you a couple of examples, and all we're going to do is find these asymptotes. That's it. And then after we've kind of found these asymptotes for a little bit, then we are going to actually graph with them. So I'm just going to call this right here example 1. And I'm going to start off with something that's not too terribly difficult of a function, just so that we can kind of get our feet wet. And then in a second, I'm going to do a really big one. Okay. So this one right here, I'm going to, there we go. So this is going to be 2x plus 10 over 4x minus 2. Now, we learned from the last section that we did on Tuesday that this right here has restricted values. And the way that you found those restricted values was you take that denominator, you set it equal to 0. Now, this particular lesson doesn't mention restricted values. What this one will mention is it will say, okay, find the equation, and they're very specific to say find the equation of the vertical asymptote. And here is why this is very, very, very heavily reliant upon what we did last time. The vertical asymptote is the exact same thing as the restricted value. They just call it something different. There it is, okay? So if you can find the restricted value of that equation like you did on Tuesday, you're done. You found the vertical asymptote, all you got to do. So remember, I'm just going to put right in here just to remind you, that is the same thing as the restricted value. So the way that we found that restricted value last time was we take that denominator, and we set it equal, or we said it could not equal 0. Now on this one, we're going to say it equals 0 because that's going to give me my equation of my asymptote. So that's your one difference. And so then if we come in here and we try to solve this, you can see that I've got that minus 2. So we're going to add 2 to both sides. And then that's going to give me 4x equals 2. And then we're going to need to come in and we are going to need to divide by 4. And y'all know we can't leave an answer like 2 over 4. That right there, that would be 1/2. And so the difference is when we did this on Tuesday, sorry, I want to say Thursday. When we did this on Tuesday, we said x couldn't equal 1/2. That's because 1/2 was a restricted value. Well, everywhere there is a restricted value, it means that there is a vertical asymptote. So my vertical asymptote is at x equals 1/2. And you actually do have to write the whole thing. You have to say x equals 1/2. And the reason that you have to say that is because of this right here. They ask you for the equation. And so an equation means that you have a variable and an equal sign running around in there, not just a number. So you can't just say 1/2, even though that is the correct number for the vertical asymptote, then you wouldn't get the correct answer because they wanted the x equals part in there. Okay. So the difference, or the new thing really on this part is going to come right here. We are going to need to find the equation of the horizontal asymptote. Now, we did not do anything like this last time, so this is going to be entirely new. So the first thing I need you to remember is a vertical line is always x equals something, and a horizontal line is always y equals something. So when I ask you to find me the equation of a horizontal asymptote, you are automatically starting with y equals. Automatically, okay? Vertical is x equals, horizontal is y equals. That will never change. So one more time, vertical is x equals, horizontal is y equals. Now, the horizontal asymptote is going to require that you go all the way back up to the function, and you actually have to look at both numerator and denominator. It's not just like this other one where we only looked at the denominator. So I want you to look up here, and I want you to notice you have two things really running around in the top and the bottom. I'm going to underline them. You have this x term right here, and then you have a constant term here. And then you have this x term here, and you have a constant term here. And so what you want to do is you want to take the highest power of x. Now you have to be real careful when I say that. You want the highest power of x. Power means exponent. So you'll notice you're not really looking at an exponent here, but you really are, because remember, x means x to the first. So these two things mean x to the first right here. So when I talk about the highest power, this has a power of x to the first, and this has a power of x to the first. That 10 and that -2 do not. So we're not going to be concerned about those. All we're going to do now is, now that I know my highest powers, I'm just going to look at my coefficients. So my coefficient in the top is a 2. My coefficient in the bottom is a 4. That reduces to 1/2. So the answer for this part would be y equals 1/2. That is my horizontal asymptote. Now, I just pulled these numbers off the top of my head when I was coming up with an example, so please don't think that your vertical and your horizontal are always the same. They are not, okay? So let's erase this one, and I'll erase that example 1, and we're going to do another one. Okay. Now, so I have a little bit more room because this next one's going to be longer. I'm going to start abbreviating. So instead of writing out vertical asymptote, the whole thing, and writing out horizontal asymptote, the whole thing, I'm probably just going to start using VA for vertical asymptote and HA for horizontal asymptote. All right, so example number 2. And here we go. F of x is going to be 2x squared plus 7x plus 6, all divided by 2x, oh, not 2x squared, I'm sorry. Let me erase that real quick. Just x squared minus 12x plus 35. Okay, so we're going to do the exact same things that we did last time, but then this time we're actually going to add, well, no, I think we won't. I think we'll just do the same things as we did last time, and then we'll go to a third problem and we'll kind of add things. So on this first part, we're going to find the vertical asymptotes, and on the second part, we are going to find the horizontal asymptotes. So remember, vertical asymptotes is like a restricted value. So what you're going to do is come in here and you're going to take this denominator, x squared minus 12x plus 35. And instead of setting it not equal to 0, we're just going to say, hey, where does it equal 0? Because that's going to give me those vertical asymptotes. Now, depending on what you did in the review section for this, you may have solved these with the quadratic formula. Most of my students that send me questions on these all factor. So since most students factor, that's the way I'm going to approach it on this particular example. But if you happen to use the quadratic formula, then that's perfectly fine. You should get the exact same answers that we do. So if we're going to factor an x squared, we know that we need an x and an x. And I need two numbers that multiply to be positive 35 and also add up to be negative 12. So that's going to be a 7 and a 5. And then remember, you have to set each one of those equal to 0. And so in this case, we get two separate equations of our asymptotes. One equation is x is equal to 7. One equation is x is equal to 5. Now in a minute, I'm going to show you what that would look like on a graph. But for right now, we have two asymptotes. So I want you to notice something. In example 1, we only had one vertical asymptote. Here we have two. You can have more than one vertical asymptote. You don't have to, but you can. Now, what you cannot have more than one of is a horizontal asymptote. So I'm going to switch colors so that we can make sure that we tell the difference. So remember, horizontal asymptote is always y equals. And you got to go back and you got to look at your function. What you want is to think about only the things with the biggest power of x, nothing else. So you can only think about the things with the biggest power of x. So if you look at your function, you've got x squareds running around. So this has an x squared and this has an x squared. And so once you know that those two things have x squared, you're not going to deal with anything else. You're just going to deal with those. And then you look at the coefficients. So the coefficient, remember, means the number in front. So this is my coefficient. So that's 2 over, and this has an imaginary 1. and 2 over 1 equals 2. So my equation for my horizontal asymptote would be y equals 2. Now, if we were going to draw this on a graph, I want you to realize what this would look like. Okay, so there's my graph. I'm going to change colors yet again. I'm going to go to like this bright green here. So for my vertical asymptotes, remember vertical asymptotes are up and down. So 1, 2, 3, 4, 5, 6, 7. Ooh, I'm going to have to move this over just a little bit. There we go. Oh, let's just do that. I think I got too close to the screen. Okay, so 1, 2, 3, 4, 5. So right here at 5, I would have a dashed line for a vertical asymptote. And then over here at 7, I would also have a dashed line for a vertical asymptote. Now, y'all give me a little bit of credit. I know they're not perfectly straight up and down, and they should be, but we'll give you a little credit on your final if you're having to draw one on paper or anything like that. So then at 2, there is a horizontal. Remember, horizontal means goes with the horizon. So you would have a vertical asymptote that looks like that as well. Okay, so now let's try to put a few things together. So we're going to go back to an equation that doesn't have as many squares as this one did. And we're going to kind of add a third step, if you will. So we've done 2 examples so far where you're finding your asymptotes, and that's what you do a lot of the time. So you're going to be in your homework, you're going to find a whole lot of asymptotes, okay? But then you're going to get to some where they actually really want you to come up with a graph. Okay, so we can do that. So for example 3, I'm going to let f of x be x plus 2 over x minus 5. Okay, so first things first, we're going to do exactly what we did on the last 2 problems. We're going to find our asymptotes, and then we're going to talk about how we can kind of put that together and get kind of a graph. So first of all, A, let's find my vertical asymptotes. All right, so if you'll remember your vertical asymptote, we're going to take that denominator. We're going to set it equal to 0. And in this case, we're just going to solve that. So if I come in here and I say, okay, plus 5, there we go. So that means that I have 1, in this case, vertical asymptote, and it is at x equals 5. Now, if you're really trying to draw some conclusions, you might notice the difference. On problem 2, that's where we had 2 vertical asymptotes. That's because that denominator was a quadratic. So quadratic meant our 2. This one, we only have an x in the bottom, and so that's why we only have 1 vertical asymptote. And then remember, for our horizontal asymptote, you are always starting out with y equals. Always, always, always. And then what you want to do is you want to come up here to this equation and you want to look at only the biggest powers of x. Well, we have an x here and an x here. And so then remember, you want to look at the coefficients. Both of those have a 1. So this would be 1 over 1. And so that simplifies to be 1. So I'm going to go ahead and write that down right here. That means that y equals 1 is the equation for my horizontal asymptote. Now let's look at this on a graph for just a second. So x equals 5. So we're going to go out the x-axis, 1, 2, 3, 4, 5. We're going to put ourselves a vertical asymptote right there. That should be right on that 5, y'all. Sorry, got a little bit off there. And then y equals 1. We're going to put ourselves a horizontal asymptote right there. And then the next thing that Hawks often asks for, so this is going to be part C, if you will, is it is going to say find 4, and it always uses 4. I'm not quite sure why, but it does, points on the graph. Now, we're not going to find 4 this evening because I think you would get bored if I did that. I'm going to show you how to find a couple of them, and then we'll just draw some conclusions. So here is the deal. Hawks is not going to let you use any X value that you want because it wants to be an X value that technically you could plot if they asked you to. So no fair using something like 1,000 for your X. Nobody's going to graph that. Nobody wants to draw out 1,000 little tick marks or anything along those lines. So what I tell people to do is generally stick to values under 10, but I also tell people try to kind of split your asymptote. And what I mean by that, if you will look at this vertical asymptote right here, and I'm going to kind of highlight it in red again, this one, this really divides my board into two parts. It divides it into essentially the part on the left of that asymptote and the part on the right. So what I'm going to do is I'm going to find a point on the left and a point on the right. So the way that I can find a point on the left is just pick any X value that's on the left. Well, you'll notice we've got a lot of them. This is an X value on the left, that's 4. That's 3, that's 2, that's 1, that's 0. We could do lots of things. You could do one, I could do another, we could both be right. It really doesn't matter which one you pick. So I don't want to pick 0 because I think 0 is going to be too easy for you. So how about this? How about let's just pick X is 3 just for fun. Okay. So if X is 3, you are now going to have to figure out what the Y is. And the way that you're going to do that is you're going to go all the way back up to that equation. So instead of X plus 2, remember my X was 3. So I'm going to have 3 plus 2 over, instead of X minus 5, I'm going to have 3 minus 5. And we're going to see what that gives me. So 3 plus 2 is 5. 3 minus 5 is negative 2. So what that means is that I have this point 3 and then negative 5/2. That's on the graph. Now, Hawks doesn't make you plot these, but since we're explaining what's going on, I'm actually going to do that because I want you to understand what's going on here. So negative 5/2 is really negative 2.5. And so if I'm over here at 1, 2, 3, and then if I can kind of draw some numbers down here, 3, negative 2.5, that means I have a point right here. Okay. Now let's pick another one, but this time I'm going to pick a value on the right side. And so since my break there is at 5, I'm going to come in here and I'm going to say, hey, this time let's pick X is 6, just for fun. Okay. So if X is 6, we're going to have 6 plus 2 over 6 minus 5. Well, 6 plus 2 is 8. 6 minus 5 is 1, and 8 over 1 is just 8. So that means I have the point 6, 8 is also on my graph. So let's put that on there. So there's 1, 3, 4, 5, 6, 7, 8. So 1, 8 would be way up there. Now, remember what asymptotes really are. Asymptotes are kind of like boundaries. A graph gets really close to them, but it doesn't actually touch them or cross them except under very special and kind of unique circumstances. So what's going to happen here is this graph is going to kind of go like this, and it's going to get close to that asymptote up there, but it's not going to cross it. And then it's going to come down here, and it's going to get close to this one down here, but it's not going to cross it. And then the same thing's going to happen over here. Oh, I'm moving that around. It's going to start here. And actually, let's move that around. Let's move that over a little bit. And it's going to go just like this. But it's not ever, ever, ever going to come down here and drop below that line. So it's going to kind of get close to that right there. Now, if you actually, and most of you do, if you have a graphing calculator, your graphing calculator typically, if you have a TI, which is what most students usually have, if you have one of those, depending on the year that your calculator was manufactured, it's not the model because like they manufactured 83s and different model years. Depending on the year that your calculator was manufactured, you can plug this into your calculator, and sometimes your calculator will draw a straight line right here. Okay. Oh, I didn't mean to erase that. Sometimes it'll draw a straight line right here. That if it does, it's trying to tell you the asymptote. But then after they did that, some of the programmers came in and said, we don't like that because it draws a straight line, not actually a dashed line, and that's actually mathematically inaccurate. And so then they took it out. So some of you will have a calculator that doesn't show you any asymptote at all. And it really is just a matter of when your calculator was made. And so then you have to turn around and kind of draw your own conclusions on asymptotes. Basically, your calculator will tell you the shape of the graph, so it would tell you these two blue things, but it's not necessarily going to give you any assistance on the asymptotes. You're going to have to find those on your own. So let's do one more. And I'm going to pick this next one because it is a bit tricky on the horizontal asymptote. And so I want to make sure that we have gone over one of these before you start working on your homework and all that kind of stuff, because it has kind of this extra little catch that the first three problems that we did not have. So we will call this example 4. And we are going to let f of x equal negative x plus 1 over x squared minus 25. Okay, so you will notice on almost every, in fact, I think every, I kind of hesitate to say that, but I think every homework problem, the very first two questions that they ask you on this section are find the vertical asymptote, find the horizontal asymptote. Remember, none of your homework problems have an oblique asymptote on there. So, okay, here we go. Find the vertical asymptote. So we're going to take that denominator and we are going to set it equal to 0. Now be really careful. This is quadratic. And so exactly like that second problem that we had, you are going to have two asymptotes here. And so remember, you can factor this. It's called the difference of squares. So we factor it into x plus 5 and x minus 5. And then we set each one of those factors equal to 0. And then we get x equals negative 5 or x equals positive 5. Now remember, on every single problem on Hawks, when they ask you for an asymptote, they are always going to say find the equation of the asymptote. So you can't just plug in negative 5 comma 5. You actually have to put x equals. So be real careful. All right, so B, we're going to find the horizontal asymptote. Now remember, horizontal asymptote, you have to switch variables. Horizontal asymptote is always y equals. Now I'll be honest, here's where the catch comes in. So for horizontal asymptote, you're going to look for the highest power of x. Well, the highest power of x that you see up here is right here. It's x squared. And so I told you in those first three examples that we're going to look at the coefficient. Well, you'll notice that the top or the numerator doesn't have any x squareds. And so the coefficient of the x squareds up in the top is 0. And then we have 1 x squared in the bottom. And 0 over 1 simplifies to be 0. Now keep in mind, that doesn't mean that there isn't a horizontal asymptote. There is a horizontal asymptote. It is just at 0. And so if you were going to come over here and you were going to draw this, I'm going to draw my x and my y axis right here. I'm going to get blue, a little bit of a different color. I would have 2 vertical asymptotes, one at negative 5. I would have one at positive 5. And then I'm going to do this really big because I want you, and kind of bold, I want you to realize you have a horizontal asymptote, but it's kind of hard to see it, especially if I would have done it in the same color as my axis, because what I really have is a dashed line on top of that axis. So you have a horizontal asymptote right there. Now, what Hawks will sometimes do is then give you some shapes. And they will say, okay, pick the correct shape of this graph. So, and they will say, pick the correct shape over here. And then they will say, pick the correct shape in the middle. And then they will say, pick the correct shape over here. What I would recommend that you do on a case like this is one of two things. A, you can plot points. If you want to plot points, it's going to take a little bit, but you can, and we will plot a point in just a second. Okay. If you don't want to plot a point and you just want to use a calculator and do a little bit of interpretation, you are welcome to do that. But what I want to remind you of, if you're going to use a calculator, if you are going to plug this into a calculator and you are going to graph it, you must make very sure that the entire numerator is in parentheses, and then when you divide it, you have to put the entire denominator in parentheses. If you don't do that, you are going to be making a mistake along the way. So just for a little extra practice, since on the last one we only found 2 points, let's find at least 2 points here for a second. So let's pick, I'm just going to pick x equals 0. Oh, there's Shane. Hang on just 1 second. Let me, hang on. Evening, Shane.
How are you?
I'm good. I'm guessing you didn't get the message about the time switch.
No, I don't guess I did. Nope.
Uh-oh. Let me finish up this problem and then I will, because this was actually the last one. Okay.
Okay. Are you gonna post it soon?
I'm sorry, what?
Are you gonna post it soon after you're done?
I will. It takes about 30 minutes for it to buffer into or not buffer, that's the wrong word. I'm sorry. It calls it converting when it puts it into YouTube. And so I will start doing that process as soon as we're done, but it won't be instantaneous because it does take a bit for it to, YouTube has to put it in their own little format kind of thing.
I could come back to that if that's
Are you
easier.
sure?
Yeah, that's no problem.
Okay. All right. Only if you're sure.
No, I'm good. I promise.
Okay. All right. All right. Have you looked at any of these? Let me ask that.
Yes.
Yes. Do you have any questions? That sounds like a yes.
I do. I don't know what they are though without looking at it though.
Okay. Then do me one favor. Hang tight. Let me finish this one problem and then I'm going to do one more that's kind of overarching. Is that okay with you?
Yes,
and that way you can ask a question if you run across it in there, and I'll just kind of cover most of the high points in that one problem.
Okay. Yeah, it may be something you answer in your lecture anyways.
Okay. Okay. So, okay. So let me finish this one. Okay. So, we're going to pick, x equals 0 for this problem. So remember, I'm going to do my little arrow back up here. Here we go. We're right up there. So if x equals 0, we have -0 plus 1 over 0 squared minus 25. And so I get 1 over -25. And so what that means is I've got this point 0, 1 over -25, which is really, really close to 0. So it's just right under there. I mean, if 1 was on here, it would be like way down there. It's right. It's kind of even hard for me to do that. It almost should be right on that origin. So I've got a point right there. And then I'm just going to pick 6 over here just so that I can pick one point out here and maybe we'll get a little bit of a bigger answer. And so we're going to pick x equals 6. And remember, you can pick whatever you want to as long as it's not an asymptote. So for this particular problem, you can't pick 5, you can't pick -5. No fair. You can pick anything else you want to. So if we pick 6, we have -6 plus 1 over 6 squared minus 25. And so -6 plus 1 is -5. 6 squared is 36 minus 25 is -11. So that would be right around in here somewhere. And so then remember, what you want to do is remind yourself that these don't really ever touch or cross your asymptotes. And so we've got our asymptote here at 0. And so if we have this point, that means it's going to do something about like this. But also remember, if you were choosing to go off your calculator would have this curve and you would just have to place it because you know where your asymptotes are because we found those, the calculator didn't find them, and you would have to kind of place it there. And then since we still have this asymptote up here and we know we have a point right here, this one's going to have to kind of turn around and look like an upside down parabola so that it doesn't cross my asymptotes. And then what I did not do, but I can tell you just because of interest of time, if we pick one more point, this one over here would be a positive and the curve would look like that. So since you have since you have two asymptotes, you essentially have three parts of the graph. Now, in my opinion, this is about as tough as it gets. Okay, so let's go back and let's do one that is not quite as daunting maybe to find all of the points, and we'll talk about how to plug it into a calculator as well. And we're also going to talk about the kind of catch on the horizontal asymptote on this one too. So since we only did one that had a catch, we're going to do another one that has a trick. Boy, we had way too much stuff there. That does not want to erase. Okay, so here we go. So we'll call this one 5. All right, so we're going to let f of x be 3 over x minus 4. Okay, so I picked this one just because it has a little bit of a catch, and we are going to do absolutely everything with this. So we are going to find vertical asymptotes, we're going to find horizontal asymptotes, we're going to find points on the graph, and we are going to graph it. They can't ask you to do anything else. That's about it. Okay, so abbreviation VA, I'm just going to do that for vertical asymptote so that it doesn't take up too much of my whiteboard here. And so remember, for your vertical asymptote, it is the denominator. So we are going to take the denominator, in this case, x minus 4, equal to 0. So it's really like that restricted value that we did on Tuesday. The difference is on Tuesday, we said it couldn't equal 0, and now we're saying it can equal 0 because that's going to give me my asymptote. And then we are going to just solve it. So in this case, we're going to add 4. And we're going to say, okay, x equals 4. Now, just because we know that we're going to do a bunch of stuff with the graph, I'm going to go ahead and put that piece of information on the graph. So remember, x equals 4. We're going to go at the x-axis. So remember, the horizontal one is the x-axis, equals 4, and we're going to go to 4 right here. And remember, an asymptote is a dashed line. So I'm going to have a little dashed line. I'm sorry about the little curvy down there. Let me see if I can do a little better. It's supposed to be completely straight. You know, we can give ourselves a little leeway. There we go. Okay. So remember, what this does is this divides my board into 2 spots. So in a minute when I graph it, I'm actually going to have to pick my pen up or my finger or whatever I'm graphing with. I'm going to have a graph on the left of that asymptote, and I'm going to have a graph on the right of that asymptote. So you're going to have 2 pieces. It's not like a parabola or something where you only have one piece of it. You will never be able to graph these things without picking up your pen or pencil. So let's switch colors now, and let's go to our horizontal asymptotes. And so the thing that most students forget is right off the get-go. Remember, for a vertical asymptote, your I should have circled that, your equation is always x equals. For a horizontal asymptote, remember, you start out with y equals, always. It's the way that it is. So vertical asymptote is x equals, horizontal asymptote is y equals. And remember, you do have to have that. You can't just say for your vertical asymptote the answer is 4. Hawks will count it wrong because it says they want an equation, and so that means they want the x, the equals, and then the number. And same thing here, they want the y, the equals, and then the number. So for your horizontal asymptote, here's another one with a trick. You look for the biggest power of x. So if you come up here and you look in your function, the only x that I see is right there. That's it. There is no other x anywhere else. And if you wanted to put a number in front of it, remember, since it's a plain x, it's an understood 1x. But the problem is that's in the bottom. There are no x's in the top, and I can't really have a fraction that has a blank space over something. And so since there are no x's in the top, that means that that's a 0. And then 0 divided by 1 is always just 0. So that means that you do have an asymptote. It is just at 0. Students all the time want to say, oh, well, I got a 0 in there, it means I don't have one. That's not the case. You have one, it is just at 0. And so I'm going to come over here and draw it really big just to kind of make it stand out. That means that you would have this dashed line right here running across the horizon because it is a horizontal asymptote, but it would sit on top of that axis. So that's another reason I drew it really big, because I want to make sure that you really realize it's there and in a different color. If I'd have drawn it in red, theoretically, you shouldn't be able to see a dashed line on top of a solid line, but it really is there. Okay, so now let's pick some points. So if I am using points, now when Hawks ask you to pick points, unfortunately, it's always time consuming because they always say pick 4 points. We're going to go ahead and we're going to do 4 points on this one. Okay. They're not too difficult to find. We may have to do some erasing in just a second, but we're going to pick 4 points. Now, remember, when Hawks says this, they don't necessarily mean you have to pick the same points that they do or that I do or anything like that. What I would do is tell you this. You essentially have 2 sides. I'm going to kind of, well, let's do something. You have this side over here. You have kind of the left side on the side of that vertical asymptote, and then you have this side over here. You have the right side of that vertical asymptote. So since you have 2 sides, what I'm going to do is just pick 2 points on the left, and I'm going to pick 2 points on the right. You don't have to, but since I'm going to use these points to graph, I'm trying to get some points kind of in both parts of my board here, and so that's why I'm going to do that. So I'm going to do my 2 points on the left in that little purple color, and you can pick any x you want. Now remember, this right here is 4. So if I'm going to pick 2 points on the left, I want to pick 2 x values that are less than 4. Doesn't really matter what they are. Let's just try 2, if that's okay. So I'm just going to come down here. I'm going to say, okay, let's just pick x is 2. So if x is 2, what I'm going to do is plug that into my formula right up here. So that's going to be 3 over x, which in my case is 2, minus 4. And so that's going to be 3 over 2 minus 4 is negative 2. And so what that means is that I'm going to have the point 2, and then negative 3/2 would be on my graph. So let's plot that. 2, negative 3/2. That's negative 1.5. That would be right about there. All right, now I'm going to pick another one. I like to pick easy ones, okay? I mean, technically, I guess you could pick negative 17, but who wants that? That's ugly. So let's pick 0 because I'm still sticking on the left. So if I'm going to pick 0, that's fine. I'm going to plug that in. We get 3 over 0 minus 4. So that is 3 over negative 4. So that means 0 and then negative 3/4 would be on my graph. So 0, negative 3/4 would be somewhere right up in here, and that would be on my graph. And so now what you have to do is a little bit of interpreting, really. So your graphs are not going to touch your asymptotes. They're not going to cross over them most of the time. Remember, I can give you an instance where they do, but it's pretty rare. But they do get very close, and they're also always curvy shaped. So they never do anything like take hard lefts or spiky points or anything like that. So if I've got these 2 points right here, I'm going to have to connect them, but it's going to have to level off. And the reason it's going to level off is because I've got that little green dashed line right there. And so they're never going to cross that little guy. And then come down here. And once again, now it's going to start pointing pretty much straight down, because here I have that red asymptote over there that they're going to get close to, but they're not going to cross that little guy either. Now here's the next problem. Students think, my gosh, this is the longest problem on the planet and I'm done, and you're not. because you only have what the graph looks like on the left side of your asymptote, and there is a right side. So it's the one thing I hate about doing these things on a computer. I'm running out of room. So I'm going to erase these asymptotes right here. And now what we're going to do is we are going to figure out what this looks like on the right-hand side. And so the way that we're going to figure out what it looks like on the right-hand side, remember once again, this, oh, I'm still on my eraser. Yikes. Let me go to red again. Sorry. This guy right here is 4. So to get on the right-hand side, we need numbers bigger than 4. And so you can pick anything you want to. Let's pick 6. Okay. 6 is bigger than 4, so that works. You could pick something like 100, but Hawks is not going to let you go that big. So yes, you could pick 100, or you could pick 3 million or anything like that. They want you to keep it relatively small and pretty close in to that asymptote. So don't go huge on me here. So if we pick 6, then if we're plugging that into this equation, we have 3 over 6 minus 4. And then so we have 3 over 2. So that means I have the 0.6 and then positive 3/2. So positive 3/2 is in between 1 and 2. So if I was 6 right here, kind of 1.5, I've got a point right there. And then just to show you that we can stick really close to that asymptote, because on the other side, I picked ones that were not right next to it. I'm going to go ahead and pick 5 here, because I want you to realize that you can just go right on the left or right. It doesn't really matter. So if I pick 5, I'm going to have 3 over 5 minus 4. Well, that's going to be 3 over 1, which is just going to simplify to be 3. So that means I have the 0.5 comma 3 on the graph as well. So that means I need another point up there. So 5, 3 would be right here. And then once again, once you get those points, you've got to do a little bit of interpreting here. You're going to get close to your asymptotes, but you're not going to touch them and you're not going to cross them. And your graph is going to be a somewhat of a curvy shape. So we know it's going to have to connect these, and it's going to have to go pretty much straight up here. But what's eventually going to happen here is it's going to have to start to turn, because I've got this asymptote in green right there on my axis that I'm not going to end up touching or crossing. Now remember, if you plug this into your calculator, this is the most common mistake that students make. So I'm going to write this down for a second. Students will do this with their calculator. They'll go 3 divided by x minus 4. And when they do that, they don't get this graph. And the reason that they don't get this graph is because if you are going to plug this into your calculator, you must remember the entire numerator goes in parentheses. The entire denominator goes in parentheses. So if I was going to plug this into my calculator, I need to put parentheses around my 3 divided by, and then I need to put parentheses around my x minus 4. I need that division to be in between the numerator and the denominator. And we have to use those parentheses so that the calculator knows which part is the top, which part is the bottom. If you don't have those parentheses in there, the calculator just guesses, and it guesses wrong. So it's kind of a, kind of a catch-22 there, really. Okay, so let me stop there. What'd you think?
Sorry, I was trying to get to the unmute.
Oh, no, that's okay.
Yeah, I think that probably that's where I was having issues. I didn't really understand where the 4 points were coming from. I guess.
Okay. The only catch on those 4 points, once again, don't pick your asymptote. So you see how we had that asymptote at 4? Because if you try to plug in 4, you're going to get 3 over 0, and you can't do that. So you just pick any x that you want, essentially, but don't pick really big ones, because Hawks does not tend to like it if you go over 10 or either direction, like over 10 or under -10. For some reason, it doesn't like it. But here's the other bad thing about Hawks. I'm going to tell you, this is one thing I've asked for them to fix, and I think it's on their radar, but they haven't yet. When they put those 4 points on there, that is one part to the question. So you could have 3 of the 4 points correct, but if you made an arithmetic error and you miss one of those 4, it tells you that it's wrong, and you don't necessarily know if all of them are wrong or if one of them is wrong. Do you kind of see what I mean? So if you happen to be doing your homework and you miss a section like that, the first thing I would do is just double check your arithmetic. Make sure you didn't lose a minus sign on one of them or something like that. Because a lot of times students, they'll miss one and they're like, oh my gosh, I obviously don't know anything. And it's not that. They've got 3 of the 4 right. They've just made a little arithmetic mistake. Or I don't know, you did 6 minus 4 and you put 3 instead of 2. You know, you just do silly things
Right.
sometimes. So that would be my first word of caution on that section, is just double check your arithmetic real quick.
Okay.
Okay.
Yep.
All right. So I am going to once again, I'm sorry about the time change. I sincerely apologize. I'm going to post this as quickly as it will allow me to. And then I'm going to tell you it was me tonight instead of Miss Young. Miss Young is going to be all of next week. But obviously, if you're doing your homework or anything like that and you have a question, make sure to shoot either one of us an email. Okay. And we'll be happy to get right back to you.
Yeah, that was my fault. I was with my wife yesterday. I had to run to the hospital. We had all kinds
Oh
of.
no, I'm so sorry.
No, we're good. We're good.
Okay,
now.
good.
Uh,
Okay.
it just kept me busy, so I didn't really pay attention to anything else.
No, it's okay. Well, and I'll be honest, I'm gonna have to be out of town next week, and that's why Miss Young is that's why I'm doing tonight. Miss Young is doing all of next week, and I'll be honest, I have to be someplace at 8:30 to deal with a kid, and so I just had to move it to from 7 to 8 instead. So I apologize. It's just, you know, feel like the end of the semester, everybody's running, right?
That's right.
So, but I once again, I apologize. I'm sorry about the time change. And by all means, I'll be checking email tonight. So if you need something, just let me know. Okay.
I appreciate it, Dr. Reed.
No problem. You have a good one. All right.
You too.
Bye bye.
Bye-bye.